Hi, today we're going to talk about dynamic landslide susceptibility. Landslide susceptibility is basically the probability or how likely the landslide will occur.
Okay, so let's say if you have a slope or if you have flat land,
Yeah.
How much it will...
So of course the probability or the likelihood of a landslide occurring on a steep slope is much greater than on flat ground. It's something we can commonly perceive. And then when we add the word dynamic to it, it means that you can actually see the susceptibility changing in time. We can compute different factors for that, for example, rainfall. So when there's a lot of rain and the slope becomes really moist, it cannot hold, it has too much water content, and then it just slides down. And that's why the probability of that slope failing or a landslide occurring increases.
Okay, and why do we need to know what's happening in the slope?
Yes, that's a very good question, because sometimes near steep slopes there is a large population residing. Not everywhere, so it can be a hazard, but for it to become a disaster, you need population living there, or industries or houses or whatever. And to protect those people from, ceasing to exist, you need to estimate how dangerous that slope is.
Okay, so what was your approach to solve this problem?
My approach is dynamic landslide susceptibility. So for that, I use some variables which define how dangerous a slope is. For example, how steep the angle is of the slope, what kind of vegetation there is, how much sun it gets. We can define that by different proxies. And then I also use the triggering factor. So there can be multiple triggering factors, but for me, in this case, it's rainfall. So I have rainfall-induced landslides, which I try to predict in space and in time. So it becomes dynamic in its nature.
So it's something that I would be using, for instance, to predict what's going to happen in a month's time or something like that?
Yes, of course. In a month's time, depending on what kind of forecast information you have for rainfall, we have a lot of different products now. NASA uses GPM, which gives a 3-hourly forecast as well. It can also predict landslides. NASA actually has a model which predicts landslides every 30 minutes on a global scale, but it has a different approach to it, and we try to modify that approach. Mm-hmm. And so the novelty of this work is the method itself. And using that, you can actually input any kind of forecast data for rainfall. We have different satellites collecting different data, which is feasible for different kinds of places on the globe as well. Like, for example, for Asia, there might be some satellite data which works really well, and for America, there might be some other. So depending on your study area, I think you can really do a lot with all this incoming satellite information.
Okay, so one of the stars of your MSc time here at ATC was that you built a pretty cool application. Will you show it us?
Yes, of course. So this is on Google Earth Engine, which is a widely, I think, I learned this in ITC indeed. So I have all my remotely sensed data already on Google Earth Engine, which I can access through the Google Earth Engine catalog. So I use that to solve a part of my model already to reduce the computation time, and then I use the other half to extract dynamic rainfall information. You can select any date you want from this date slider. You can go in the past, but you can only, from today, you can only visualize the susceptibility for a month and 2 weeks before, because of the lag time the data is available on this platform. So let's say I select 13th August, and I just have to run the model. It will do everything on its own, and it will divide the susceptibility based on the probability of the slope failing. It will either be a warning or a no warning for the end user. It takes a bit of a time to visualize because of, a lot of mapping units. So I've already run the model, and this is what it will look like in the end. And the red ones are a warning signal, and the green ones are relatively safe.
Okay, so if I were to live nearby one of the red areas, then
Yes, you would need to see how much it's raining and how close you are, of course, in which direction of the slope you.
And which region is that we're looking at?
This is northwest Vietnam. I mainly chose this region because of availability of data, of course, because that's very important. So I had landslide inventories which were dated. They were actually mapped by NASA as well. They aimed to implement the same global model on a regional scale. So I made use of that data and I did my MSc work in northwest Vietnam. And that's actually one of the most vulnerable regions as well, where you have a lot of storms, tropical cyclones, and different precipitations, rainfall systems coming in.
And who does a software like this going to be used for by let's say layman or?
Yes, of course, that's the beauty of it. I think the idea to visualize this based on just a simple link is so a layman or my brother who doesn't know anything about this can understand what's going on. What does this mean? And I have a very short description. It's also like technical, but if you really want to know what's going on, I have a link to where the thesis can be found, and it's very nice app with a cool interface. And once you actually, you have a graphical representation, you actually would understand more what's going on. You would explore more rather than if you have to read like I don't know, really long thesis, which nobody would want to do for something they don't know nothing about.
Okay.
Yeah.
Well, thank you very much for this interview.
Thank you.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.